A company estimates that it will sell N of X units of a product after spending X thousand dollars on advertising, given by N of X equals negative 0.25x to the fourth plus 13x cubed minus 180x squared plus 10,000 for 15 is less than or equal to x is less than or equal to 24. We have two questions to answer. One, when is the rate of change of sales increasing and decreasing? And two, what is the point of diminishing returns and the maximum rate of change of sales? Both of these questions have to do with the rate of change of sales with respect to changes in advertising spending. So we are talking about the first derivative, n prime of x, that would be the rate of change of sales, and we are going to use the second derivative, n double prime of x, to answer our questions. So I'm going to go over here where I have written down the formula, and we need first the first derivative, so n prime of x equals negative 1 x cubed plus 39x squared minus 360x. So that's our first derivative. That's the rate of change of sales. And in order to investigate when it is increasing and decreasing and what the point of diminishing returns might be, we need the second derivative. So n double prime of x, which is the derivative of the first derivative, negative 3x squared plus 78x minus 360. I'm going to set the second derivative equal to 0 in order to find when it changes from positive to negative. So we'll say 0 equals negative 3x squared plus 78x minus 360. So we can factor out a negative 3 and we end up with x squared minus 26x plus 120. And inspecting this, I can see the factors are x minus 20 and x minus 6. So there are two places where the second derivative is 0, or two inflection points, or two possible points where there is a point of diminishing returns. They would be x equals 20 and x equals 6. But if we look at the domain of our function is defined between 15 and 24, which means x equals 6 is not in our domain. So we are only interested in x equals 20. I am going to draw a number line for the second derivative. And the point where it is 0 is 20. And the point, this is defined from 15 up to 24. Okay, so we can look, we have to be a little bit careful here. We're going to look at n double prime of x, and I'm just going to rewrite that as negative 3 times x minus 20 times x minus 6. Remember, when we factored it down here, we divided by negative 3, so I'm just putting it back in. This will make it easier for me to tell whether or not my function is positive or negative, whether or not my second derivative. So if I look now between 15 and 20, this negative 3 is negative, x minus 20 is negative, x minus 6 is positive, so we've got positive times negative, so the second derivative is positive. That means the first derivative, the rate of change, is increasing. If I look between 20 and 24, let's say 22, we've got a negative number times a positive, and so the first derivative is decreasing. So we have, let's see, the rate of change, n prime of x, is increasing on 15 up to 20. We have n prime of x is decreasing from 20 up to 24. and n prime of x, the rate of change, is maximal when x equals 20. And if I plug 20 into the first derivative, I get n prime of 20 is equal to negative 20 cubed plus 39 times 20 squared minus 360 times 20. I need a calculator. Negative 20 cubed plus 39 times 20 squared minus 360 times 20 is 400. So this is equal to 400. So the rate of change when I increase advertising, the rate of change and increase of sales is maximum at $20,000, and that rate of change is 400 units per $1,000 of advertising.